Thank you. So I'm going to be talking a bit today about college and career readiness and a focus on equity across the grades there. And so the college and career readiness track spans early childhood all the way through high school and then beyond into lifelong learning. And SRI has conducted a wide range of research in different aspects of college and career readiness. And today I'm going to focus on one particular project in the middle school, Sunbay Mathematics. And one thing to notice is this is a little bit different use of research than some of the things we've heard about today, and that this project is an example of how research can also directly lead to the design and implementation and creation of materials. And we chose middle school mathematics because it presents one of the biggest barriers in preparing students for success in higher level science and math. It's during middle school that students are expected to understand algebraic thinking. We go beyond additive thinking to multiplication thinking. We're thinking about ratios, proportions, and we know that this really is a barrier to many students. So that's our focus of our talk today. So as with Shari, our projects at SRI tend to be large partnerships. So we partnered with, again, the University of Florida Lastinger Center, the University of South Florida, St. Petersburg, Manatee County Public Schools, Broward County Public Schools, and Palm Beach County Public Schools. And our most recent study was funded by the U.S. Department of Education. I3 stands for Investing in Innovation program, and the Helios Education Foundation. And a lot of the work I'm going to talk about today also was funded by the National Science Foundation, as well as other foundations. Our goal in equity was to prepare all students for success in algebra and higher level mathematics. And this really requires that we prepare teachers to teach conceptually rich mathematics, as well as engage students, not only in the mathematics itself, but in the mathematical practices that we know are so important to being able to really be successful in the world of STEM later on. And so we designed and developed technology-based curriculum materials and professional development, the curriculum materials, the technology, and the professional development as well, that was both based on and also added to the research based on what we know about the teaching and learning of mathematics. And in the end, we created a series of 2 units, each of which were about 2 to 3 weeks long, in each of grades 6, 7, and 8. And each of these units, students investigate foundational math topics through the use of what we call dynamic representational technologies. So what I mean by dynamic representational technologies is, in this particular example, students are learning about slope and about, sorry to get a bit detailed to you, but y equals mx plus b, right? And what does that mean, and why do we have that crazy equation, and what's it all about? But instead of putting it on the board, this is this definition of slope and this delta y and delta x everywhere that no one quite understands. What we have is students actually model a race using graphs, right? And so students make predictions about what will the race look like. Can you make a race that looks like this? How can you edit the graph so it does this? And students themselves start to wonder, well, how fast are these guys going? How can I tell how fast they're going? Right? It's often easy to tell how fast they're going when their graph starts at 0, 0, but how can I tell how fast they're going when they get a head start or they start off behind, right? And through this, they start to develop an intuitive understanding of slope, and then we do introduce the equations at the end, and they're asking their own questions about it, right? They're asking, what does it mean, right? How can I calculate the slope? Well, how can I take into account a head start? And all of a sudden over here, these start making a lot more sense, right? The equations start making a lot more sense. So that's really the goal of our materials. We do this in multiple content areas, but it's really to give students the intuitive experience that the mathematics makes sense to them, not tell them the math and then have them practice it, right? And we think this is really important. This does help prepare you for STEM careers. When you don't know the answers, you actually do have to make sense of phenomena and try to use mathematical and scientific reasoning for making sense of the phenomena. I'm not going to say that much more about Sunbay, and we do have some videos of teacher use and things. And in your bags are these little orange pens. And in these little orange pens, there's a website on them. So if you want to see like a video on what Sunbay is and learn more about it, and also the pens are also touch pointers for your tablets or phones as well. Just don't extend the pen part when you use your tablet. So feel free to take a look at that. After this session, learn more about what Sunbay really is. Now, the Sunbay materials themselves are based on over 20 years of research and a wide variety of evidence. And the evidence started with early feasibility and case studies, where we were really iterating on these ideas and what should the technology look like? What should the activities look like? How do we really get students not to just kind of go off tangent and start playing with the graphs in non-productive ways, but how do we focus their questions so they really start kind of honing in on the important mathematics? That progressed to small classroom studies where we had teachers who, we knew were very enthusiastic about this. We knew could do this work and we were excited about doing this work. And then to an RCT and then onto a full RCT of a small RCT, but it showed large gains on unit assessments, right? And then these gains were first in Texas, then replicated in Florida, and also replicated in the UK. So here's an example of our first randomized controlled trials in Texas and Florida. This is not the large study I'm talking about now. And what we see is that in our control group, students, the dark colors are questions about basic mathematics, and the light colors are questions about more deep and conceptual mathematics that often aren't tested on end-of-year assessments. And what we see is that the students that use Sunbay scored far better, especially on the conceptual areas, than those who did not. And another way to look at this is this much more complicated graph, but this is broken out by each individual classroom. And what we see is that over on the far left, right, the control students, there were very few gains really on the deep conceptual math, whereas as you get further towards the right, we see far, far more of the classrooms that use the Sunbay materials, again on this unit test of deep conceptual materials. And you do see that there's a few of these white bars, right, that are actually to the far right. And those are the miracle teachers, right? We know those teachers are out there. We know they're 1 out of every 10 teachers, the teachers every parent hopes their kid get. But it's rare. And what we do is we find that far more teachers can behave like the miracle teachers in helping their students understand deep and conceptual mathematics. Right now, we then had our most recent study, which was conducted in a diverse set of districts and schools and really focused on schools in low-income communities. And again, this is a large randomized control trial that used the end-of-year Florida State assessment as its outcome measure. Right, and we had some really interesting studies, really interesting findings from this that we're really thinking deeply about right now. One is that we did see that Sunbay students engaged in higher level discussions in math practices. And this is all done by an external evaluator as well. And their video and their coding showed that students really did engage in higher level discussion in math practices. We found that the Sunbay teachers, compared to teachers that did not have the Sunbay intervention, increased on a subscale of TPAC, technological pedagogical content knowledge, and also another standard measure that shows are teachers more willing to allow their students to engage in productive struggle. Right, and so in many classrooms, we get very much the teachers tell the students what to do, and if there's any struggle at all, it's a problem that must be immediately remediated. Here, the teachers are very willing to let their students engage in some of this struggle, some of this figuring out that really helps to lead to a deeper conceptual understanding. However, in the large randomized controlled trial, there was really no difference in the FSA scores. And I'll talk about that again in a minute. But again, that's the end of year Florida State assessment scores. Right. Now, there was a smaller design study, and people are here from all the districts that were in this, by the way, so we can talk to them later. In our smaller design study, we actually do show a significant increase in FSA scores. It was not a randomized controlled trial. It was more sophisticated statistical techniques that you have to use for that. Right. And so we have this this interesting difference in scores in the FSAs. And based on observations and alignment with the goals for teacher practices, the districts that use Sunbay actually have included Sunbay units in their pacing guides and their professional development offerings, right? So from that perspective, it was a great success, right? Districts used it and decided to keep on going and using it. And so, this really shows we have a question about the alignment, right, of what it means for actual college and career readiness, engaging in the mathematical practices, engaging in student struggle, engaging in more deep kind of conceptual understanding. But what are the end-of-year assessments actually measuring? Are they measuring these things that are actually most important for college and career readiness? And I think that's a significant question for people to think about and understand how can we get to that. And if it's not, what does that mean? What can we do as a community to help say, what's important is not a single 8th grade end-of-year test score. What's important is that we're preparing our students in a way that really makes sense for them, right? And there's not also a bias towards good test takers, which we know is a significant equity issue. So that's a question that I think this really raises for us. And what would Sunbay look like if we actually had assessments, right? Would the results look different if we actually had assessments that measured what matters in moving forward in the world of STEM? And we think that it would. And again, we already had increased scores in one instance, not others, but we think our things would be much more robust, again, if we had really much more aligned measures, right? So, and this is not only for Sunbay. We have another area of research I was talking about at my table before, where we're looking at mathematical modeling and 3D printing and how we can align that to the standards. And again, that even looks further off than Sunbay from traditional test measures. And teachers, understandably, because their job depends on it, are very focused on the traditional test measures, right? So there's a bit of a concern about what's the uptake of these innovative materials that can prepare our students, that can have significant equity impacts. But if teachers can't use them or won't use them because they know their job is to prepare students for this test, and what you're giving us looks nothing like the test. I want textbooks where my students are constantly answering questions that look like what they'll get on the test, right? So we have some real significant equity issues here, I'd say. And and Paul pointed to before, it's another way to look at this is that challenge between balancing innovation with results, especially when results are on existing measures. So what does it mean when our innovations look different than existing measures, right? So I think, Paul, you really pointed out to an important question there. So anyway, that's all I have to say on this, really. We're really interested also in others that are thinking about some of these ideas, and I'd love to kind of talk with you a bit later and share what does it mean and how can we work together both to engage in these innovative ways of teaching mathematics or STEM in general, and what it means for how do we actually show the impacts of them. So I'm happy to talk to folks later on about that. Thanks.